This is a video from the Chapter 6 review. We're going to look at problem 10. The base of a solid is a circular disk of radius 3. Find the volume of the solid if parallel cross-sections perpendicular to the base are isosceles right triangles with the hypotenuse lying along the base. Okay, so we have a circle centered at the origin with radius 3. Now, the equation of a circle centered at the origin with radius 3 takes on the form x squared plus y squared equals 9. If I solve for y in terms of x, I get y equals plus or minus the square root of 9 minus x squared. Okay? Now, if we look at this point on the circle, it's going to be of the form x positive square root of 9 minus x squared because that point is in quadrant 1. And if I take a look at this point, and remember, it's straight down, right? Like so. This point takes on the form x negative square root of 9 minus x squared, because this point is in quadrant 4, so the y-coordinate has to be negative. Now, the distance from this point all the way down to this point, I claim, is 2 times the square root of 9 minus x squared. And remember, in the problem, that's the hypotenuse of a right isosceles triangle, right? Where this side, the two legs basically are the same. And so we need to know what those legs are. Now, I'm going to call the length of one of the legs A. So if the base leg is A, the other leg is A. And by the Pythagorean theorem, we know that a squared plus a squared is equal to 2 times the square root of 9 minus x squared squared. So 2a squared is 4 times 9 minus x squared. Divide both sides by 2. That's all I did on the next line, right? And I get a squared is equal to 2 times 9 minus x squared. Solving for a, we get a equals square root of 2 times the square root of 9 minus x squared. All right, now that allows us to get the area of this right triangle. So a of x is 1/2 the base times the height. The base and the height are exactly the same. So it's 1/2 square root of 2 times square root of 9 minus x squared, that's the base, times the height, which is square root of 2 times square root of 9 minus x squared. So this is equal to 1/2 times square root of 2 times square root of 2 is 2. So we get 1/2 times 2 times. And then now, square root of 9 minus x squared times square root of 9 minus x squared is just 9 minus x squared. The 2's cancel, and we're left with 9 minus x squared. Now we're ready for the volume. The volume is the integral from negative 3 to 3 of 9 minus x squared dx. So this is 9x minus 1/3 x cubed evaluated from negative 3 to 3. Pop the 3 in, we get 27 minus 9. Pop the negative 3 in, we get negative 27 plus 9. And I have to subtract those quantities right here. So this is 18 minus a negative 18. And the correct answer here is 36. Now, you might ask, well, how did I know to put the hypotenuse perpendicular to the x-axis, and why didn't I make it perpendicular to the y-axis? Well, I could make the hypotenuse perpendicular to the y-axis, and I claim you would have gotten the same answer in the end. Like, how would that have looked a little different? So, if I draw my xy plane, like so, right? And I'm going to draw another circle right here. Now, the equation of the circle doesn't change. It's x squared plus y squared equals 9. I'm going to solve for x squared to get 9 minus y squared. So x is plus or minus the square root of 9 minus y squared. And so all that would have happened is I would have had square root of 9 minus y squared here and y here. And I would have had negative square root of 9 minus y squared with the corresponding same height. And my hypotenuse would have been perpendicular to the y-axis. The distance would have been 2 square root of 9 minus y squared. And my volume would still be the integral from negative 3 to 3, right? And it's basically would have been 9 minus y squared dy. So my volume won't change whether the hypotenuse was perpendicular to the x-axis or perpendicular to the y-axis. And that's how you do problem 10. Okay, thank you.